Hey there, welcome back to another video. We have a 480E. It's out of a 1993 Chevy Suburban, and the situation here is that it was having delayed engagements in both forward and reverse, and eventually lost reverse. So we're going to take it down and see what's up with it. Now the vehicle has 300,000 miles on it, and the transmission itself is either a replacement or an overhaul or both. I believe the customer told me it's his father's vehicle, so he thinks that the transmission's been either completely replaced or overhauled at least twice previously. So we'll go ahead and take it down. It's 4x4, and in 93 you'll notice it has 2 speed sensors. Even for the 4x4s, was the last year of this, and 94 and up they did away with the output speed sensor in the transmission and just leveraged the transfer case speed sensor. So the extension housing has already been removed by the R&R tech, so we can go ahead and start ripping into it. So 8mm on our speed sensor bolts. Always replace your speed sensors. Never reuse this kind of stuff. Anything electrical or electronic on a transmission should always be replaced. I mean, there's very few exceptions to this, but for the sake of what we're doing here today, any GM transmission, you always replace your electrical components. Alright, so we'll spin it around. See, we have a hydromatic tag over here, and then this is the traditional lube circuitry design. So you have your supply and your return kind of next to each other. 97 and up, they went to a rear lube or center lube design that prioritized the rear gear set for lubrication first, and the fitting would be located somewhere in here, right around here. So you notice back here you have a snap ring. This snap ring can be removed pretty much at any time, and it retains the rear case seal. The 4L80s have that. The 4L60E, 700R4s, H350s, they do not have a rear case seal. So we're going to just keep this aside for cleaning. Alright, wiring harness. Never reuse your wiring harness in 4L80s. They have a tendency to start leaking through the connector, and it can sometimes short out the the electrical circuitry and throw the thing into limp mode. The other thing I notice here is you see what appears to be either engine oil or something to that effect. You see it here in the bell housing, just a lot of dirt and a lot of grime kind of built up. So when you see stuff like that, it's a good idea to advise the customer to inspect the rear main seal and anywhere else where oil can leak in the back of the engine. Alright, if you're having torque converter issues, and the customer has complained about torque converter concerns, check this O-ring here for the converter clutch circuit. I mean, as you can see, it's coming apart just like my glove. So I mean, I don't know if this was split on removal of the converter or if it became like that during the course operation, but when you see stuff like that, you want to kind of think about the amount of heat potentially sustained in the transmission and see if there's any bluing, especially in the overdrive section. So things like steel plates, backing plates, things of that nature. Alright, let me get a glove and then we'll resume. Alright, gloves on. So 13mm in your pump to case bolts. 4 to 22 thous should be your net end play. This looks like it has about 60 or 70,000 gross end play, but you really need to be loading the rear section and then net out the snap ring to the input shaft and overdrive carrier to compute your final end play for the front. That said, this seems like it's a tad excessive, but it could be perfectly normal. Maybe it was just on the higher side of spec with respect to the front end play, like 22, 23 thousandths. Like I said, the spec's 4 to 22, but if you were like 24, 25, it's not the end of the world. If you're any higher than that, then I would, take corrective action on it. All right, let's flip this thing over. All right, I think customer drained most of the fluid out of the pan, but we still have some left in there. 10mm on all your pan bolts. These get anywhere from between 95 and 110 inch-pounds. You can torque them up even a little further than that. If you're putting an aftermarket deep pan on here, then I think a lot of them tell you between 120 and 140. So I'm thinking the pan was taken off. I mean, some of the bolts are loose. Obviously the bolts are extremely filthy. The whole thing's filthy. Fluid stinks. It's like a reddish black. And we have quite a lot of burnt clutch material in the pan. Alright, let's get some of this fluid toward the cloth. Alright, so we have an aftermarket filter made in China. A lot of times these filters can get clogged up, and that'll cause the symptoms that you described, delayed engagements, no movement. I mean, usually it's a product of some other massive failure inside the transmission, and this just exacerbates the problem, let alone being the sole cause of it. Alright, if you're new to 4L80Es, you want to know that there are two different generations of them, 91 through 96 and then 97 and up. The valve bodies are completely different between the two in terms of like interchangeability. You cannot put a 91 to 96 valve body into a 97 and up case. It just simply won't work. And this is the principal reason why you notice this very long feed tube here. It runs from the front of the valve body to lubricate the rear case bushing. So in 97 and up, they went to a completely different tube, and that tube inserted in this area, right around here in the valve body, and went to the rear case. And so that's again owing to that major engineering change that took place starting with the 97 model year transmissions. So I just kind of pry up on it in both spots, and it'll eventually come out. So electronic pressure control solenoids changed. 91, 92 had a silver can, and that's what appears that what we have here. So let's see if they put a 92 valve body on this thing. It's a 93 valve body, but they have a 91, 92 style silver can EPC on here, so that's interesting. And then 93 and up, the harness and the EPC electronic pressure control solenoid changed. So if you're working on a 91 or 92, or you have a 91, 92 separator plate and an EPC installed onto 93 and say through 96 4L80, then you're going to need to kind of do whatever mods that need to be done to make sure that the new EPC will work with that configuration. But if you see that, and if that's what's going on here, then my recommendation is to simply update the separator plate to match the year of the valve body casting as well as the year of the case, so that everything aligns. So 1993 and up, they did away with this silver can EPC, and they went with the Bosch sealed EPC. These are vented, so the valve body is not vented, and what I'm talking about is for EPC balance, EPC venting. So bottom line, if I have to summarize all that gibberish in like a simple, easy to act on 1 to 2 sentence blurb, 91, 92, the silver can style was installed, and you need to replace it with a 93 to 2000 EPC because these are no longer made. And then if you're working on a 91, 92, then you have to follow the requisite procedures to adapt your 91 or 92 valve body and spacer plate to work with the 93 and up electronic pressure control solenoid. So hope that wasn't too confusing for you. Alright, and this is one of the principal reasons you want to replace things like the wiring harness. I mean, everything is literally falling apart in my hands. The connectors are disintegrating as I'm taking them out. So you don't want to reuse any of this stuff. I mean, this has been through God knows how many miles of heavy duty towing, hauling, working, whatever the vehicle and transmission has been put through. When you're doing an overhaul, you don't want to put dirty clothes back on a clean body. And that's what you would be doing if you reused electrical components. And that's a 10mm. Okay, pressure switch manifold assembly. And then this is your transmission fluid temperature sensor. In the 4L60Es, the fluid temperature sensor is integrated in the pressure switch. In the 80s, it's part of the harness. And out comes the entire harness and into the trash it goes. Alright, get that one bolt, and then we'll take the valve body off. So we got the stack side of it, you have your gasket, and then you have your accumulator stack for the third and fourth accumulators. This is going to be a factory build, so we're not going to block this off. It'll go back on. Depending on the condition of the accumulators, this bolt was loose. Depending on the condition of the accumulators, you know, specifically the pistons, we may need to replace them. Got one more. Alright, so this little valve and spring here that you see on the far side, I guess from your point of view, left side, is going to be the torque signal compensator valve. So this is set up to facilitate what we have, or what we call an electronic pressure control solenoid cleaning cycle. So that was an integral part of the whole EPC framework, or electronic pressure control strategy, for these earlier units, 91, 92, and apparently early 93. So, you know, we're seeing a 93 casting with a torque signal compensator valve installed, and you know, apparently all the requisite components for that very early setup. So you don't need to do anything special with that. Just, you know, put it back in, put it back on exactly as it was. And then for your housing, you're going to have a pin here with an E-clip, and then you're going to have your pistons, and as you can see, these are falling right out. So when you see stuff like this, this tells you that there was significant leaks here at these two apply circuits. Since the accumulator circuits are sub-circuits to the main apply circuit, all the fluid has to go through those accumulator circuits to achieve that kind of dampening effect, because an accumulator is basically an attenuator, if you will, for all your shifts. It slows down the shift to, you know, make it not so jarring, so that it's not backbreakingly harsh or uncomfortable. I mean, that's their job. They're basically mechanical dampers. And so when you have extremely worn seals or sealing rings like this, you're going to have a lot of blow-by, and ultimately that's going to compromise the holding and clamping force that's available to your applied elements in the case. So it makes sense as to why we see what we see, at least insofar as fluid color. I mean, these things are toast, so they'll need to be replaced. Alright, and then here are your springs, factory springs. No different than, you know, any other. And then insofar as the E-clip, there is an updated version of this. So this clip came right off, which tells me it's wore out. So I'm probably going to put an updated one in here, a whole accumulator piston and pin kit. They are available. Alright, I'll mess with this later. Alright, spacer plate. See, it's heat bonded to the valve body. So again, when it's heat bonded like this, you know there was just a ton of heat sustained. So you have my second gear, third gear, and fourth gear. These orifices don't look like they were drilled. This looks purely 100% factory to me. And so we can get some of this gasket off here. 4LADEs have a real bad problem with actuator feed limit valve wear and also accumulator valve wear as well. So you always want to vacuum test everything. I got a couple of different 4LADE vacuum test videos out there on the channel. Valve body and pump assembly. So, you know, I'll get into more details when we, you know, get to the pump. But suffice to say, hydraulics are often the underlying driver behind all sorts of failures in any automatic transmission. I mean, it's basically a glorified hydraulic pump. So Be interesting to see how this thing tests. You know, a priori, I would suspect it's got at least somewhere in one or more of these valve trains. See if I can get this close up to you. You can see 93 on there. Maybe not. I don't want to touch the camera. It's, you know, going to get all nasty ass fluid all over it. So put the valve body in there for now. Just get some of this crap out of the way. Get that E-clip where it needs to go. Probably put another, like I said, I believe the accumulator piston and pin kit comes with a new E-clip, a little snap ring or whatever you want to call it. Alright, so here's your check ball configurations. So reverse check ball, the two accumulators for second or for third and fourth, that's these check balls here. It's your direct clutch check ball. I haven't memorized the other two because frankly I don't really mess with them or touch them. But if you're doing something high performance, and again I have plenty of videos that show this, and you're blocking off the 2, 3, 3, 4 accumulator stack, you would omit these two check balls here. And then if you wanted a more robust shift into third gear, you would eliminate this check ball, and same for reverse, you would eliminate this check ball. The others, unless you're running, you know, I guess a specialized kit or whatever, they have to remain in their respective locations. Alright. So you have this little nail thing here, retaining the selector shaft, and then you also have a 15mm nut. You get up in there. Alright, that's loose. And then for the nail, you got to be real careful. So you just want to get good purchase on it with like a pry bar. And pop it straight out. Alright, last thing you need is to have this thing broken off into the case. That would absolutely suck. Alright, selector shaft came out nicely, didn't fight me. I don't see too much of that on the 4L80s, I do on the 4L60s. I mean, they're constantly fighting me. There goes the selector shaft seal. And then you have your rooster comb with your parking rod assembly, like so. Alright, get that nut. Alright, 13mm on your parking pole guide plate. Nothing to really think about here, other than obviously don't over torque the bolts and strip them out. The only other recommendation is I would leave the little return spring in place so that the pole doesn't interfere with the whole gear train when you're trying to drag it out of the case when everything else has been removed. Okay, 10mm on your low reverse piston housing cover. The 1-2 accumulator is also inside of here. So a lot of times no reverse is just simply, especially after an overhaul, is failure to torque these bolts. Like when you go to air check it and you just zip them down with an impact, you know, low power impact, you'll have a ton of leakage between the cover and the gasket. Okay, this has the flat top design. These are not known to be troublesome, but the 96 and up dome style pistons are known for cracking, so I always upgrade those to a Sonex billet aluminum piston in that location for anything 96 and up. But for a stock build, any TH400 or earlier 4L80E up to 95, it's not strictly speaking necessary. Okay, here is your co-span servo. So this changed, I want to say in 1999. And the servo was, I believe, elongated because the band got wider. And you can retro that updated combo to these earlier units or anything earlier. You just have to retro them as a service pack. You can't just swap the band, you know, swap the servo. All right, nasty, nasty. So 1-2 accumulator piston, you can kind of just do a quick check on the seals. I mean, this was sealing a little bit better than the 2.3 and 3.4, but not by much. I mean, it's just heavily wore out. And then, of course, you have your E-clip here. See if I can get it out. A lot of tension here, so you just want to be real careful. Let me get the screwdriver. There it goes on the floor. So you obviously don't want to lose this. Alright, so here's the arrangement, if you will. There's a little spacer here for your spring seat, and then you have the spring and the pin, and then you have your front spring retainer here. Pretty straightforward deal. Alright, for your servo, it's a good idea to check your working surface in here. Okay, make sure that it's not like, I should say sealing surface, make sure it's not wore out. And we have what appears to be a witness pattern, and this one here. So once this is clean, I'm going to have to inspect it a little bit more closely, but I don't like this. I don't like the look of that, so I'm probably going to have him replace it. So again, complaints of no reverse, something like that will absolutely cause the band to burn up. Alright, last things we need to do is to remove these two feed bolts. This is going to be your center support feed. You need a 3/8 12-point socket, and then you need a Torx 40 socket for the overdrive feed bolt. So overdrive feed bolt gets 12 or 13 foot-pounds of torque, so 144 to 156 inch-pounds. And if you're going to install a transgo shift kit, they give you like an Allen-headed type bolt for that location. Do not use it. I can't tell you how many times those bolts have stripped out on me. I mean, I stopped using transgo shift kits in these transmissions a long time ago, but when I was using them, I learned pretty quickly that that bolt was not to be used. It just loves to strip. Alright, so we're almost done with the case belly. Let's just extract this bolt. Looks brand new. Here it comes. This one's shiny. Alright, so let's go ahead and remove this pump. Maybe tidy the bench up a little bit, get some crap out of the way. I'm going to turn the transmission so it's facing you. Alright, for pump removal, you can get up in here with a pry bar, no big deal. I like to have my hand over the input shaft because I don't want everything else coming with it. So just kind of work both sides and it'll come out. Alright, so you see we have these old school Teflon sealing rings. I don't like them. I mean, every early 4L80E that I've pulled apart, I would say about 90% of them, these sealing rings are heavily wore out. These don't look too bad. Here's your selective washer. This is what actually regulates and, you know, sets your front end play. See how thick it is. 90 thousandths. 90 thousandths by far the most common, at least that I've seen. And it usually works most of the time, you know. But sometimes you got to swap out for a super thick one or a super thin one. I mean, the last one I built, I had to use the thinnest selective washer available to get, you know, to get over the minimum spec. I think I ended up with a net front end play of about 15 thousandths on that deal, and that was because I needed to get at least, I like to have at least 3 to 4 thousandths more end play in the front than I do the rear when you net out the snap ring on the you know, on the overdrive plant and input shaft. All right, let me see what kind of angle I have. It might be okay. Okay, pump bolts 13 millimeter. Okay, myriad of problems associated with these pumps. Working surfaces are often warped or scored up. The stator support, which is this thing, and then the body, which is the other half. Other problems include wore out boost and or pressure regulator valves, the torque converter clutch limit valve. If that's worn, you'll start stalling out when you put the thing into gear, either reverse or drive. So we'll take a look at the pump body first. Let me move you up a little bit. and kind of shoot the camera face down so it's looking at these things and not kind of at a side view. Because otherwise you're kind of side-eyeing everything and you don't really see what's going on. Alright, so here's your gears. Your orientation is the flats. Basically come to the top and you have dots to indicate which side faces up. If you plan on reusing these gears, make sure that they're not cracked. Make sure this area here on the flats isn't mushroomed. A couple times I've reused gears and I didn't notice that, and I couldn't install the torque converter, and you know, obviously that was a problem. I had to pull the whole pump apart and replace the gear set. Alright, for the driven gear and the drive gear, you're going to check teeth, make sure there's no excessive wear, check the outer diameter here, and of course you're going to do all this after the parts have been cleaned off. So I'm just kind of showing you what to do and maybe where, but I'm not really doing any kind of credible inspection at this point. Alright, working surface here in the pump itself, you want to check the crescent. As you can see, this appears to be heavily worn. No surprise. I can get that to focus. Heavy wear on the crescent, but the wear appears... Actually, no, I take that back. It looks like it's got a little bit of a bias over here. So in other words, more wear in this area. So this area is not as worn, but then it gets real worn over here. So he's going to need a pump body. What you would normally do is when you pop this seal out, assuming the body check's okay, you would drill the drain back to 1/4 inch on all 4L80s. I mean, you know, you can argue it's not mandatory for factory builds, and that would be fine. I mean, I'm not going to argue with you, but I do it on all mine just because. Last thing I'll touch on is this gap right here. It's a large rectangle. This is how you know you're dealing with an early pump, 91 to 96. Now 97 and up, there's a partition wall here. 97 and up bodies will be retro to all years pump stator support assemblies, but you cannot install this on a 97 and up pump stator support. Okay, time to change out the battery. Alright, new battery. So I think I've said everything I want to say about the pump body, so we'll put that to the back of the bench. Now let's take a look at the stator support assembly. So always check your splines here. I mean, it's very unusual that I see them bad, but you know, again, it's best practice to always look at that stuff. Also, you know, check your inner diameter here as well, so that you don't have you know, any kind of problems with sealing, ring groove, or you know, ring cut as it's sometimes known as. A lube mod that you may want to do on anything that's going to be, you know, kind of working heavy duty towing, hauling, or performance is to drill this out 125 thousandths. This is your lube for the Overdrive roller clutch assembly. So I covered all these lube mods in my lube mods video, and so if you're curious about the details, you want to see it done, you can check that out. Alright, what I like to do with these working surfaces, I'll take a straight edge and I'll put it right over. First I'll test with feeler gauges, then I'll use a flashlight. But in my experience, I would say about every 6 to 7 in 10 need resurfacing on the working surface. And based on just what this looks like, you know, nasty ass fluid and all kind of burnt material, I'm venturing to guess that this is going to be no different. So let's grab a straight edge and a 1/1000th of an inch feeler gauge, and you can just lay it across here and see if you can get that feeler gauge to dip underneath. Last one I did had like almost I want to say 2.5 thousandths, almost 3 thousandths of clearance. This is actually not looking too bad. Okay, here we go. So we got a little bit of clearance underneath here, maybe a 1/2 thou. That's the general idea. I don't like any kind of clearance whatsoever. Especially on a heavy-duty transmission. I have to assume it's going to be used to, you know, to the extent that GM intended for. So here's your pressure regulator valve, here's your boost valve, and then here's your TCC apply valve, and then here's going to be your torque converter limit valve. So test here for vacuum on the limit valve, test here for your pressure regulator valve end plug, excuse me. Because basically that's what you're really testing. You're testing the sealing integrity of that plug, see how well it's you know, sealing against the bore there. Here's your inboard and outboard boost circuit, and then your TCC apply valve circuit is here. Don't see this bad too often. this is always leaky, but that's no big deal. We install a Sonic's O-ring boost valve and sleeve kit there. It's going to be this one that's going to kind of, you know, this one and actually this one. If this valve is not checking well, like maybe 11, 12 inches when you want to see 15 inches, install Sonic's line to lube or lube pressure regulated, lube regulated pressure regulator valve. I mean, that's a mouthful. Install that part there, and that should bring it back up to par. Now, if you're at like single digits here, you can, I would probably just replace this with either a new or a good used stator that, you know, doesn't have sealing integrity issues. But I think you can ream this out and put an oversized valve, and I'm not 100%. I've never done it. It's going to be this valve here, the torque converter clutch limit valve, right over here, that's going to make or break you when it comes to reusing the stator or not. Because if this is bad, and you'll know it based on drivability symptoms and or vacuum tests, then you'll want to just replace the pump. Alright, so that's pump assembly. Again, these 91 to 96 pumps are not interchangeable with anything 97 and up, so don't mix and match different generations. Bad things will happen. So here's your overdrive assembly, and then you have your overdrive clutch housing with the clutch in it. So let's take a look, see what we have. And then here's your coast clutch. We'll look at that in a second. Alright, Borg-Warner frictions, they look okay. He didn't report any concerns in fourth gear. A lot of wear on the steels. It could be just dirt, but always put a steel module on these things. Don't ever try to reuse the steels, not recommended. And even with the new steels, you got to make sure that they're truly flat. Every once in a while, I'll get a steel mod, and there'll be like a, you know, 1 or 2 steels that are actually warped, you know, literally right out of the packaging. Okay, this clutch is a little bit wore out. I mean, it's got some material left on it, but not much. Alright, so there's the clutch, steels, and backing plate. Let's check that backing plate real quick. These backing plates changed. I want to say it was either 2001 or 1999. 99 to 2001 saw a lot of changes in these transmissions, and a lot of times I will get mixed up. So you want to check for any cracking, any bluing, anything that would indicate this backing plate's no good. I mean, all these backing plates are powdered metal, so, you know, I mean, they're really not unlike the connecting rods and engines in that, you know, too much stress, that means they are, you know, prone to failure, especially when they go back in. All right, for your overdrive housing, all you need to do to get the snap ring out is to just simply collapse the return spring assembly, and then kind of get the snap ring started, and then just progressively work your way around until you can get it all the way out. And just press down. There we go. And once you get a few of these bosses released, then it pretty much just comes right out, and that's it. And you're going to install that snap ring pretty much in the exact same fashion. You're going to use your forward drum to kind of prop up your apply piston itself, and then you're just going to go like this with it. So lip seals are going to face this direction for the housing and this direction for the piston respectively. These two lip seals are not the same. They look it, you pull them out of the package, they will look exactly the same insofar as diameter and size, but they're not. This one is ever so slightly larger. So if you try to put this lip seal into this housing, you'll have a lot of problems getting it to fully seat. And that will be your cue to indicate, hey, I have the wrong seal in the wrong location. Alright, one other remark I'll make about the pump is you want to inspect the bushing wear. The bushing wear is very asymmetrical in the pump body. like this. I mean, you can see this bushing, it's got some bronzing here, you know, still some color. And then on this side, it's got almost none left. I mean, I'll have to look at it closer once that's all cleaned off in the hot tank, but you want to make sure that you don't have a lot of asymmetrical wear patterns in both the pump crescent and the bushing, because that could indicate severely worn out main engine bearings, and that would be no good. All right, so we got the little snap ring there. So I can get it off with these little pliers. If not, I'll have to get some different ones. So this is what I was talking about earlier when I was referring to snap ring play. You'll see anywhere from about 10 to 30 thousandths. I mean, it all depends. But you have to net that figure out of your end play measurements so that you don't, you don't arrive at the wrong reading and conclusion about how you've adjusted your front end play. All right, for input shaft, pretty straightforward. Check journals, check splines. Here, spline engagements on this end and this end for the converter. You want to make sure you blow air or solvent or whatever you're using to clean all your parts into here. Make sure nothing's clogged up in there. Otherwise, you'll have problems. All right. Well, this bushing goes to the forward drum, so this completely walked out. Omega Machine makes a wide forward drum bushing. For anything high performance, I like to install it. Now, this is not the reason why I do it. I mean, it better stabilizes the journal and basically the whole front end of the transmission as far as these two assemblies are concerned. But this walking out would indicate to me that there was a lot of contact being made and basically a lubrication-driven issue. So roller clutch rotation is counterclockwise, freewheel, and locks clockwise. They always replace your roller clutch assemblies or one-way assemblies, roller clutches, sprags, mechanical diodes. There are some exceptions to that, but not many. So these are Borg Warner. This roller style changed to a much smaller roller assembly in 2001, and that changed the cam here on the drum itself, the inner race here, or the outer race I should say, on the planet. So again, you can retro that as a service pack if you want. It's not recommended. I actually like these larger roller styles better, but don't just swap parts individually when it comes to the planet and the drum here. I mean, roller clutch. All right, so coast clutch 3 and 3. So we see some more signs of wear here on the steels. Frictions look reasonably okay. I mean, no slip marks or anything like that. Put this stuff back here. All right, forward drum. In fact, let me finish up here with the coast clutch drum. So you want to check in here for wear, for ring cut, on the Stator stealing rings is very, very rare. I see it. Check your lugs. Check your teeth here on the sun gear. Check the lobes here on the cam. Make sure they're not worn. I mean, again, this is not an area that I see too many issues with. All right, for your planet, you're going to do your checks first for your inner race. Make sure that this race is okay. Now, let me see if this is actual heat soaking or if this is just dirt and crud. Nope, it's not coming off. So you want to look out for stuff like this. You see how hot these pinions got? And I noticed when I was spinning it, it was a little shaky. So like it seemed like it was having trouble turning. And this pinion is, yeah, it's kind of seized up or partly seized. So this planet's no good. I mean, you got a lot of bluing here on the journal from the bushing walking out due to lack of lubrication. This thing must have been ran low on fluid or something, so that needs to be replaced. Look at the sun gear teeth. And 4LEDs by nature are hard on bushings. And a lot of it is owing to lube related issues. And unfortunately, a lot of that is due to owner-operators not changing the fluid out at the factory recommended intervals. So for anything heavy duty, especially if you live in a hot, arid, dry climate like I do, I'm in Vegas, so you live out here, Phoenix, Vegas, Inland Empire, you know, Southwest, you know, United States, SoCal. I mean, you really need to service your transmission probably once every 18 to 20,000 miles, maybe once every year. Fluid change out if you're doing a lot of towing and hauling and working. Hey, this thing is heavily worn out. I mean, I feel like if I flex a little bit, it'll break. So a lot of heat damage there. I mean, look at all this heat that was sustained here. So when we see forward clutch that looks like this, the first thing you want to do is eyeball the inner diameter and see if there's ring cut or ring grooves cut into the inner diameter of the drum by the input shaft sealing rings here. So that's those sealing rings there. They would be the guilty party. And yeah, we have a lot of ring cut. They seal that wear there. That would easily explain the forward clutch being smoked. So delayed engagements and drive, I mean, you know, we found the direct cause for that. And then I think I mismatched the order here. I was gonna say somebody put the freaking cushion plate in the middle of the stack. I think I did that. But suffice to say, this set of reluctor teeth, this is where your input speed sensor, that's what it reads. So what we do here is this gets bored out by my machinist, and he will put a ductile iron sleeve in there, and that will fix this drum. So that has to be done. And I'm probably going to have him replace this hub because it just got completely smoked. And same with this backing plate. I mean, you can see all the wear here. So I don't like to put stuff like this back in. I mean, maybe you argue that it's fine, you just clean it up. I mean, you know, that's fine if that's kind of how you want to approach it. But I'm a more conservative builder because for me, I have a much lesser tolerance for risk due to the fact that I'm a one-man shop and I don't have like enormous cash reserves that a very large shop or a reman company may have. You know, risk tolerance is directly proportional to scale and you know, the scale of your business. So if you're a one-man shop, sole proprietor, you know, it's more or less necessary to be on the conservative side when it comes to making judgment calls about the reusability and serviceability of parts that come out of the transmission. All right, let's grab this direct drum. All right, so direct drum again saw a lot of heat. I could see clutches are smoked. So this thing was just absolutely wore out down to its very last bit of you know, life. I mean, charbroiled. Okay, the clutch snap rings for the forward and direct clutch are exactly the same, so you know, don't worry about keeping track of them. And they're not unlike any others in the transmission, so you won't mistakenly put them anywhere else. Okay, so the cushion plates here, this is how they go. The conical side actually faces you. This style of cushion plate I'm not crazy about. They tend to break. I'm surprised one of these two hasn't broken. So as you can see, I mean, absolutely smoked. So when you see stuff like this, you also have to really pay attention to your hydraulics. Like I was mentioning earlier, pump and valve body. It's absolutely necessary that you have the capability to conduct vacuum testing. If you do not have that ability, you do not have the tooling, and you build more than, say, you know, I guess 1 or 2 transmissions every several years or so, you want to invest the money into acquiring that capability, because I mean, otherwise you're not going to have any idea as to the health of the hydraulics, and that's where it all starts. Like I always say, it begins and ends with hydraulics, you know. All right, backing plate right there, and then for your intermediate sprag freewheels clockwise and locks counterclockwise. For a second I was trying to spin it counterclockwise. So that's normal, that's what we expect to see. Let's see if we can get this out. So spiral lock snap ring, it's a good idea to retro these to TH400s. They use a traditional snap ring there, and I'm not crazy about it. So 34 element heavy duty sprag, Borg Warner. Always replace your one-way assembly, so this is going to be no different. And then check this race, both the outer race and the inner race. The inner race has to be mirrory smooth. If it's not, then the drum has to be replaced. The outer race, you actually don't want mirrory smooth. So you see here it's got mirror shine on the perimeter, top and bottom, but in the middle where the sprag actually rides, it appears to be okay. So 320 grit sandpaper will go all the way around a whole bunch of times, and that will freshen up that surface and prepare it for the new sprag when you go back with it. Alright. I'm not crazy about these aluminum pistons either, but for a stock build they're okay. So we see some witness marking here going all the way around the perimeter. I can't tell, I mean I can't feel a groove, but again that's when you do your inspections when it's clean, so that you can check with your bare hands on a clean part. Check this area here for ring cut for the center support ceiling rings. Check the structure, make sure it's not broken anywhere. You know, mostly common sense stuff when it comes down to it. Okay, coast band. Nothing remarkable about it. I mean, it doesn't look like it was used much. Alright, intermediate clutch. So let me see if I can change camera angle so you can see into the case. There we go. So for a stock to mild performance build, anywhere from 45 to 60 thousandths clearance is fine. Anything high performance, high RPMs, we're going to be taken off like at full throttle, wide open in first gear. You really want at least 75 thousandths of clearance in here. Chris at CK Performance tells me that like when he's building something for all out race or stock or you know pro mod, he'll actually go right up to 125 thousandths of an inch. And how he knows he's good is he'll just take a 1/8 drill bit and you know on the shank end and go all the way around, make sure it fits in there nice and you know evenly, and he knows he's good to go with his clearance in the intermediate clutch pack. Alright, so this will always be replaced with a Chrysler Ford clutch A518, A618, 727 selective snap ring. 88 thousandths is what I most commonly use, sometimes 75 thousandths. The thicknesses are kind of all over the map with those. I mean, the book specs call for 106 thousandths, 88 thousandths, 73 or 74 thousandths, and I think there's one thinner one than that. But I've seen all kind of variations, so you know, just whatever your hard part supplier has or can get, you know, that's what you can grab up and install. All right, let's take a look at these frictions. So, no signs of slipping on this steel here, but we do see a lot of heat sustained on the friction, and that's going to be true of all of them. So again, ran low on fluid, probably a lot of towing, hauling, and working over the course of its life, and it just gave out. So that's my theory anyway. Again, with all backing plates, check this. For high performance, high RPM, run the Sonics either billet or forged backing plate. There's two different styles. There's this early style with the ridge here, or the lip, and then there's the late style that's thinner. It's about roughly this thick here, but you know, all the way across. And you'll beef up that intermediate clutch and reduce the likelihood that you might experience a catastrophic failure at the backing plate. Alright, now we have our center support snap ring and center support slash, you know, I guess everything on back of that. That's the gear train. So let me go ahead and get a different screwdriver so I can grab up on that, and then we'll go through the gear train and we'll be done. Alright, let's see where I want to attack this thing. Maybe not there. When you go back with these, it's my recommendation you straddle this opening with the snap ring. I mean, I'm not liking this too much because it's you know, kind of a pain to get at. And I always put the opening at the large opening here on the inside of the case. And the way they have it, it's like tough to get at, and it's also tough to kind of extract it from the lugs. There it goes. Alright, that was probably as painful for you to watch, if not more so, than it was for me to actually get it out. Alright, now what we're going to do is grab up a tool that will allow us to take this entire rear gear assembly out of here in one shot. So this tool is available on eBay. I think it's called just a 480E rear gear set lifting tool. I mean, if you watch my other 480E videos, you've seen it countless times. It's basically this thing right here. So it goes right here on the little gap right at the base of the splines of the sun gear and the journal. So what we're going to do is I'm going to grab up the output shaft and just maneuver this forward until I can get the gear train free of the rear of the case. And then I'm just going to pull it out. Alright, see all kind of issues on the front planet, band surface, right away. Alright, we got our anti-fretting ring in here. So these were installed, I believe, in 71 and up TH400s, and the center support changed. It got a little thinner here in the lugs. It's a piece of something. Alright, our band. That band's smoked. Alright, and then we should have a 3-tab thrust washer back here somewhere. Maybe it's on here. Yep, it's on here. So the 3-tab thrust washer is selective. Numerous thicknesses are available. This is what you use to adjust rear end play if you're not going to rollerize the case. And then you have your 4-tab babbitt washer. It goes on the output shaft flange here. And what I like to do is take this and put it on the front of the rear planet in place of the plastic 4-tab washer. Normally goes there. This and that washer are exactly the same thickness. This babbitt washer and the washer you'll see in a minute or two are exactly the same dimensionally, but the babbitt material was obviously more resistant to heat and stress than the plastic one. Alright, let me just empty this case. Nasty ass fluid out of here. Nasty. All right. Straggler check ball. Alright, let me just go get a pair of snap ring pliers so I can yank that last snap ring out of there. Alright, and then for the seal, I mean, you may be able to get at it with a pry bar here. Take it out. New one will come in the kit. So, inspect the case as well. So you want to check your bores for your accumulator as well as your servo piston seal. I'm going to check all the way around. Again, you're really going to do this when it's clean, not when it's dirty. Actually, this could probably stay in here. Alright, let's take a look at the gear train, then we'll be done. It's going to take a little while in the hot tank to clean that case. It's disgusting. It's disgusting. Alright, so I already see some things that I don't like. So it looks like we have what appears to be a walking bushing for the sun gear shaft. Yeah, so let's take taking stuff out, apart. So here's our center support. It's our sun gear shaft. And yep, this bushing is worn down. I mean, saved me a little bit of work there, and I have to pull it out myself, but we'll have to really scrutinize this shaft to see if it's okay to reuse. It's possible that a new bushing will not actually install. In other words, there will no longer be a press fit here. So I got plenty of those. I'm just going to swap it out proactively, and then, you know, if I want, I can check it later for bushing and, you know, the feasibility of installing a new bushing. But, I mean, this is all that's left. All right, let's look at this bearing. This bearing's seen better days. So put a bearing kit in here. Here's your thrust washer. This goes back here. So you see all the heat sustained on the journal. I mean, the amount of parts that he might be into this for might be more prudent to get him another core that isn't so destroyed. So we got a chunk missing out of the retaining portion of the snap ring groove there. So center support has to be replaced. Not good. I mean, I've seen worse, but this one is probably the worst one I've seen in about, I would say, 2 years. Alright, so you see this is all bent out of shape. This is very flimsy. You would never actually use the stock return spring assembly in any kind of performance build. I always install heavy duty spring retainer and high rate return springs, and that pretty much mitigates the risk of failure with respect to the spring retainer for the intermediate clutch. Alright, I think I'm going to pull the pistons out too, and then we'll take a look at the lip seals to see if they're hardened, because for the forward and direct drums, I mean, they are absolutely charbroiled. So my guess is that there's probably a hardening of the piston seals. Drum seal doesn't really matter, but the piston seals definitely do. So we got a chunk there, a little divot. And this surface feels rough to me, even with a glove on. I mean, it could be just the grit on my hands, but I mean, look at the bushing there for the center support. I mean, Jesus Christ. So center support's no good. It'll have to be replaced. Okay, you always want to know your casting numbers. That's going to basically be your best bet for center support identification. Now, these early units, it's easy to tell, because all you have is the 2 feeds for your direct drum and your intermediate, but there's no cooler port here, so I know you're working with a pre-center loop designed center support. Alright, so let's take a look at the planets. You have the sun gear, and when you're going back with these things, you want to make sure that your lube locations are aligned. So here's the lube in the sun gear shaft, and you spline that in right here. That was right. And then you just take a flashlight to confirm that you are in fact aligned. Because if you're not, I mean, you could end up with a transmission like this. Unfortunately, I wasn't able to preserve the arrangement pulling it out, but maybe they weren't aligned. Okay, here's your low roller clutch, and then you have a support that goes in here in the planet, and it just comes out. So you just want to make sure you buy the correct roller clutch for your application. There's one with legs, and then this one without. Jump right here. Alright, So obviously this Planet's seen better days as far as band surface, so a lot of slipping in reverse. I mean, you know, more or less squares with what the customer was telling me. But if this surface isn't too horribly damaged, and I'm not talking about this particular surface, I'm talking about here in general, you can smooth it out with some sandpaper. You can chuck this in a lathe and, you know, put like a sanding strip over it to clean it up. You can turn these. I typically don't like to do that because then it complicates band clearance on a reassembly. It's best just to get a good use Planet if it's, you know, really messed up. Okay, your bushing here gets replaced. Check your cam lobes for wear. It's got a fair amount of vertical play in this Planet compared to that one. These are rebuildable. My machinist rebuilds them. So I'll take this one to him and get his thoughts, see if it's something he thinks it's worth doing. If not, then I'll just get a good used one. And I believe I have several in stock, so it's probably what I'm going to end up doing. Anyway, all right, here's that 4-tab plastic washer I was referring to earlier. So this will be swapped out for the Babbitt one, and then in place of the Babbitt washer and the 3-tab steel selective washer, you would put your TH350 pump bearing and shim kit. Usually 15 to 25 thousandths worth of shims get you where you need to be end play wise, but that's how you would go about it. All right, so we have a race and then Planet. Let me get this snap ring off of here and we can have this fully disassembled. Looks like I don't have the correct screwdriver on the bench, so I'm gonna have to ad-lib with picks and such, and I don't know, it's not going well. Yeah, not going well. I mean, normally I would do this with the hole in the bench over, you know, to your right, but it's occupied. There we go. All right, so here's your output ring gear to output shaft thrust bearing. So you have the bearing and then the 2 races. The top hat goes on like that. And then on the inside you have your sun gear thrust bearing to the rear ring gear. Hey, 99 and up 4L80Es. They have a 41,000 shim in this location. That's because they changed the design of the planetaries. So what they did is they removed a little bit of meat here, and looking at this, this looks like a 99 and up Planet to me. Actually, now that I'm thinking about it, now that I'm looking at it, this looks like a 90, basically a 91 to 98 Planet. I'm wondering if that's the problem in here. I don't know. I'll have to grab a 99 and up Planet. I'll take a picture of that and this and compare them. I mean, it's hard to see with everything all dirty and not something to directly compare it to. So I could be talking out of my ass. We'll check the Planet for serviceability, and then I'll tackle that other mystery later. Okay, check around here too for structural cracking, bluing, like you saw in the Overdrive Planet, all along your pinions. Check here as well, same deal. Check teeth. Check this surface. There's sometimes a black oil lube dam or what have you there. So we have our reluctor gear. So again, 93. They had the speed sensor active for 4x4 units in the output location. And then this is what you would typically see for an output shaft for a 4-wheel drive vehicle. So check these splines as well, check journal, checking here. This bushing looks like it's not walking. So a couple bushings have walked, several others are worn down to the, you know, very, very bare basics, so to speak. You know, their interior, you know, lining or whatever, you know, the core. Gotta take this little snap ring off here so we can clean these. I mean, you don't really have to remove this. I mean, I always do, but you didn't do it. It's not the end of the world. Alright, so one thing you're going to want to do for all these main shafts is take some 320 to 400 grit sandpaper and sand down with a particular focus of emphasis on the leading edge in each one, so your outboard edge. A lot of times when you install new sun gear bushings in the shaft, it'll get caught up on a little lip here that exists, and sometimes you can't even see it. You can feel it, but it's there. And that's a lot of the reason why you have to condition, or I should say clearance your bushings, because they'll get caught up. So, all right. It's following day and we have all the parts on the bench that are not going to be going back into this transmission, at least not without some significant reconditioning, except for the case and the two rear planets that you see on the far left side. So this was nothing short of a catastrophic failure in terms of the number of hard parts impacted and the scope and nature of what we saw. I felt that after cleaning everything off and, you know, looking at everything again, doing my real inspection and so forth, I wanted to film a separate autopsy segment instead of just rolling with the summary, you know, kind of more or less done at arm's length at the end of the teardown. So I felt that this would give you a little bit more valuable insight into what happened in this transmission and more importantly why, and help you possibly avoid this fate yourself with your 480 or TH400 rebuild, or if you just simply own a vehicle equipped with one of these transmissions, you'll have some, you know, a better sense of direction when it comes to maintenance and sustainment for a heavy duty towing and hauling working type vehicle. So let's get a little bit closer to the bench and we'll you know, kind of dive into it, so to speak, and I'll walk you through exactly what I think happened and why, and I would be curious to hear your point of view as well. So go ahead, leave in the comments what you think occurred and what you think the reasons were, and we can have a discussion there as well after you watch the video. Alright, before we get into the damage assessment, I want to just close the loop on something that I had mentioned earlier, and that is the rear planet. So I had stated that I suspected this might be a 99 and up planet. This is the planet that came out of this transmission, and then I grabbed the TH400 planet off the shelf to do a quick comparison and see if the pinions, meaning the length of the pinion from front to back, are any different between the TH400 planet and this planet. And after looking at them, I realized that they were largely the same, at least immaterially different. So I wanted to close the loop on that, lest anybody think that, you know, somebody inadvertently put a 99 and up planet in here. I mean, there was a lot of mistakes made with this build, don't get me wrong, and we're going to get into them, but putting the wrong rear planet in is not one of them. So besides that, nothing's wrong with that planet. It'll go back in. So let's talk about the modes of failure here that we saw. We have three types: structural hard part failure, bushing failure, and applied element failure. Now, applied element failure is going to be par for the course. I mean, the whole reason the transmission's in your shop in the first place, or on the bench for overhaul, is because it's suffered some sort of applied element failure, at least chances are. The other two failure types are a little bit more remarkable, so to speak, and that's what I want to spend the bulk of this part of the discussion on, so that we can better understand what happened and why. So, we'll take a look first at the rear section and the direct run. So first off, the front planet has a severely warped band surface. My advice to you, if you have a band surface that comes in looking like this, is to simply replace this planet. I would not turn it. And the reason for that is you're going to end up having to take a significant amount of material off of here to get the surface true again, to where you have nice fresh metal to work with. And in doing so, you're going to complicate and frustrate your ability to dial in your band clearance as it should be. So you measure band clearance indirectly in these transmissions and TH400s by virtue of measuring servo travel. So when you assemble the servo, what you do is you put the servo back together. Do not install the perimeter seal on the servo piston, just leave it off. And also leave out the 1-2 accumulator piston and its spring and seals. Install the servo into the bore here, fully assembled case. You got the pump and everything in. And then go ahead and press down on it until you cannot, have it move any more inboard. And then what you're going to do is take a dial caliper and measure from the deck surface here between these two bolts and the top of the servo piston. And whatever that measurement is, that's going to be the figure you use to infer band clearance. And you want to be between 125 and 175 thousandths of travel on that servo. If you take the amount of metal that you're going to need to take off of this planet, you're probably going to be at least 50% greater than the high side. In other words, maybe 250 or 275 thousandths or maybe more. And if that's the case, you're going to have to do all kinds of stuff to get yourself back into where you need to be, including welding the pin or finding an unusually long pin. And I mean, that's, to be honest, a waste of everybody's time. So when you have something like this, just get a new planet or a good used one with a good surface and put a new bushing in it, check it, and otherwise, roll with it. All right, so let's talk about what I think is the main event here, and that is the structural damage that occurred on the direct drum and the center support. So I admit I completely missed this. I did not notice it when I was pulling this drum out of the case. I was more focused on other things. But as you can see, you have 3 significant fractures all along the very top here, the inboard portion, the spline portion of the drum. And you also have a big chunk taken out of the snap ring groove area here in the center support. So what would cause something like this? Why did this happen? In my view, there's only one reason that this could take place, and that is failure to set up the case correctly. And what I mean by that is failure to set and adjust all of your travel spacing between the different sets or groups of components that you need to do when putting the case together for a 480E or a TH400. So you have your rear gear end play, but within that gear set you have your relationship between your front planet and your rear planet. Okay, so there should be a little bit of space between the two, just like this, but it should not be excessive. And you have to measure that to confirm or deny that that is the case. So if you're a little bit, you have a little bit too much play, then you can shim the thrust washer to tighten it up a little bit. All right, that obviously wasn't done here. There were no shims present. And then, of course, there's rear gear end play itself. It needs to be between 6 and 24 thousandths, I believe, or something very, very similar to that. I like to shoot for between 10 and 12 thousandths in the rear and about 15 to 18 or so thousandths in the front. And that's net of the travel between the snap ring, the input shaft snap ring groove, and the overdrive carrier assembly. So you have to subtract that to get your final front end play. And, of course, you do this measurement with the rear section loaded, so the rear end play is completely taken out, of your measurement. So what I believe happened is this transmission was set up extremely loose, and recall at the way beginning of the video we did our hasty end plate check, and it had quite a lot of travel in that input shaft, and I estimated it to be between, I think I said 65 or 75,000, something like that. I mean, maybe 50,000, I don't know, I can't remember exactly, but the point is that when you measure end play hastily like that with the transmission horizontal, figure to add about 50 thousandths or 50% or so to your measurement if you were to do it with the transmission vertical like you see it here. And that's the correct orientation to have the unit in when you're measuring any kind of end play or travel, at least with 480Es, TH400s. Some other transmissions like Ford and Dodge units, the 3 speeds and the 4 speeds, you can measure their end play or end float with the transmission case fully assembled horizontal. So I believe that way too much interaction, violent reaction interaction was happening between these components here, and to a lesser extent the forward drum, causing the damage that you see on the direct drum and the center support. That's what I suspect happened. All right, now as far as bushing failure, the second mode of failure that we saw here, we had a bushing come out of the sun gear shaft, and then we have a bushing that walked away from the forward drum. So we'll go ahead and move the camera down and take a look here and try to understand why this would have happened. So here's the bushing, here's the forward drum. And as you see, that bushing just goes right in there. If you have a situation like this, don't try to install a new bushing unless it's a custom machine bushing that's thicker, you know, here, thicker this way than a factory spec bushing. The only company I know of that would make such a bushing for you is Omega Machine. They already make a wide bushing for here, but they may be able to make a custom bushing if you have a failure like this to, you know, continue to use the drum. And then you would have them also bore the center out and sleeve it if it's worn out like this one is. So if I can get the surface rust off real quick. But as you can see, it's got a lot of wear there. So that wear would explain why the forward clutch burnt up. I mean, that, and to some extent just, you know, use and you know, the intensity and severity of use that the vehicle and transmission saw. As far as the failure in the direct clutch, I'm convinced that that's, again, combination of use as well as failure to replace the seals on the overdrive and third gear accumulator pistons in the accumulator stack. And why I believe that's the case is simply because I don't think whoever rebuilt this transmission actually disassembled the valve body at all. It looked completely untouched to me. All the electrical components, they're original. You know, the solenoids, the pressure switch manifold assembly, the wiring harness, I mean, all that stuff to me looked either original or it came in with the unit when GM manufactured it way back when, you know, in the 90s or something. So anyway, when you have a hub that looks like this, where the surface is very, very uneven, I mean, this is the clutch bearing surface for your backing plate portion of the direct clutch hub. You want to replace that as well. And then you also want to replace the hub itself for your forward clutch if it sustained this much heat. Like, I don't trust this hub, it's not going to go back in. And then same with this drum. I don't trust this drum to accept a new bushing and do it reliably, so it's also going to the scrapyard. Alright, for your overdrive carrier assembly, alright, you see heat like this, don't ever reuse that. Again, I believe that this is due to a combination of use and possibly ran low on fluid, possibly torque converter problems, although I did vacuum test the pump and the valve body, and hydraulically, suffice to say, this transmission was in very good shape. Valve body passed with flying colors. There's literally no impairment whatsoever in any of those valve trains, and same with the pump. The only thing I didn't test was the boost valve, and that's because I install a Sonic's boost valve in place of the factory boost valves in 100% of 4 LEDs I do, so there's no point in testing it prior to installing that boost valve kit from Sonic's. But the Planet itself is scrap. I would never trust this Planet again looking like this, the amount of heat this thing sustained. I mean, you can rebuild these, but you know, if this wasn't the case, this damage wasn't here and it just had like one bad pinion like this one over here, that's an easy fix, to be honest. But you know, with the housing looking the way it is, I'm not confident that it'll last. All right. So I talked about the Stator Sport. The only thing we really need to do is have the machined, or have the working surface remachined. The splines look good. The inner diameter where sealing rings go, that looks good. The journal looks good. So install our Sonic's boost valve, and you know, have a machine, move on down the road, not necessarily in that order. I want to talk more about the pump body because I think this is more important. So you'll notice here on the bushing you have severe wear, but you also have asymmetric wear. So in other words, there are portions of this bushing that are clearly and distinctly more worn than the rest of it. So here you can see some, you know, bronze material still left on it, but over here, I mean, it's worn down completely to the Babbitt core. And when you see that, the first thing that you want to consider is potential main bearing wear or failure in the engine itself. If you have excessively worn main bearings, that crankshaft is going to oscillate inside its bore as it's spinning around and rotating, and it's going to bring the flex plate and the torque converter with it, and that's going to directly affect the pump. So what happens is, with the drive and driven gear, you know, installed, and you have a worn crankshaft spinning and rotating and you know, bringing the flex plate converter along with it, the hub is going to force thrust the drive gear hard into the priming crescent, and the converter hub is going to be asymmetrically forced against the bushing, and it's going to start wearing it out. and it's going to, you know, take on more of an oblong shape, you know, the bushing that is. So when I have a conversation with the customer, I'm going to have him remove the oil pan because you got to do an oil change anyway. And in addition to doing the rear main seal, I'm going to have him first check longitudinal end play on the crank, and then pop the oil pan off, pop the couple main caps off, including the main thrust bearing, and see if there's wear there. If so, I'm going to let him know he needs to rebuild the engine before the vehicle goes back on the road, because I will not warranty the transmission if it comes back looking like this in, you know, a few thousand miles or so because of excessive wear in the main bearings in the engine. So anyway, that covers pretty much everything I wanted to cover. I wanted to share what I thought happened and all the different factors that went into this failure, and more importantly, relay some tips and things that you need to have you know, in mind so that you can avoid it for your TH400 or 480E equipped vehicle. Or if you're thinking of building one of these transmissions yourself, what to look for on teardown, how to recognize signs and symptoms of certain things like misassembly or, you know, poor judgment calls on part selection, as well as other subsystem potential issues like worn out engines that could endanger your build through no fault of your own. You know, you don't want to be in a kind of a pissing contest, so to speak, with your customer when the thing comes back because the pump ends up looking like this again, and you say, hey, it's you know, main bearing wear in your engine and I'm not going to cover it, and the customer said, well, you never said anything about that. I mean, you know, you want to de-risk all of these potential outcomes up front so that you have them accounted for, and also stated in your warranty paperwork what you cover and what you don't. This would not be covered, and that's a conversation I'll have with my customer once I brief him on what I found. So anyway, as always, guys, thanks so much for watching. Greatly appreciate it. If you have any questions, comments, go ahead and leave below. Otherwise, I look forward to seeing you in the next one. And again, thank you so much for spending your time on my channel. Hey there, welcome back to another video. And if you're watching this as part of the appendix section in the teardown inspection video for this particular transmission, I guess, you know, welcome again. I wanted to film this particular video because I wasn't happy with the way I treated the valve body section on teardown. This is a 1993 unit. It's out of a 93 Chevy Suburban 2500 HD, 3/4 ton, and of course we're dealing with a 4L80E here. So when you're working with a 91 through to 93 4L80E transmission, there are certain things that you're going to need to be mindful of when it comes to the valve body, the spacer plate, and electronic pressure control solenoid. All right, and the reason for that is 91 through 93 used a slightly different configuration and design with respect to all three of those components. And this is due to the fact that there was a different electronic pressure control strategy built into or designed into the command and control framework for these transmissions that changed in 94 and up. So for starters, let's take a look at what we have on the bench. This is everything that we would need to fully assemble this valve body. We have the valve body casting itself, and that's hiding under here beneath the gaskets. The two gaskets, one for the valve body to spacer plate, the other for the valve body assembly to the case. And then we have the spacer plate that came out of this unit that's associated with this valve body, and it's a 1993. And then for comparison, I have a 2000 spacer plate from a 4L80E core that I tore down, I don't know, I think about 6 months ago or so. And then we also have all of our new electrical components, including the updated electronic pressure control solenoid that we'll talk about, and why updating to this newer design solenoid is important in context of what you have to do to adapt your 91 through 93 valve body and spacer plate to accept this updated solenoid. So if you guys have been around 4L80Es and you know you've kind of been there and done that, this is not going to be anything you don't already know. But for those of you that are thinking of building a 4L80E for the first time, or maybe you've built maybe a few of them, I don't know, but you've never worked on one of these really early transmissions, this video may be of interest to you and may help you along in this particular part of the build. So first off, let's talk about what is different. So starting with the valve body. These valve bodies, 91 and 92 and 93, are designed to accept what we call the silver can style vented electronic pressure control solenoid that was manufactured by Bosch at the time. And that solenoid went hand in hand with a spacer plate that was designed to accept it, or designed for it, as well as an accumulator housing that utilized something called a torque signal compensator valve. So these early units had a different design accumulator housing. Of course, you have your 2-3 and 3-4 accumulator pistons here, just like any other 480E housing. However, you also have a third stack, and this is for your torque signal compensator valve and spring. And this is part of the EPC functional strategy, if you will. It's technically part of a cleaning cycle that's executed by the PCM to facilitate, I guess, clean and consistent operation of the solenoid to ensure that line pressure is appropriately managed at all times inside the transmission. So with that said, the valve body itself in the area of the electronic pressure control solenoid is not vented. So in other words, if we take a look at the instructions that Transgo provides on their website for their SK480E shift kit, they give you a quick comparison here, an image of each of the types of valve bodies that I'm referring to in the area of the electronic pressure control solenoid. And the 91, 92, and 93, at least some of them, including this one, are non-vented. So if you look in this area, which I'll show you in a second in the valve body itself, you'll see that this area is fully casted over. There is no vents of any kind, no ports, no exhaust, nothing. When you move to a, well, they're saying a 93 and up, but in reality it's 94 and up to be 100% certain. This entire cavity is vented through and through, as you can see. Let me try to zoom in. Alright, so hopefully you can see that. I mean, this little viewfinder, it's hard to tell, but the point is that you want to make sure that you have this in mind, you know, this entire, I guess, you know, difference and adaptation process that I'm going to cover, which is very simple, by the way, when you're working on these earlier 480E transmissions. So let's take a look at the valve body real quick, and then we'll go to the spacer plates. So I've already modified this one, but here is our silver can EPC. This is of the vented variety. Okay, it's made by Bosch. And let's see if Bosch has its name on it. No, they don't, but you know, here you can see, you know, Bosch Germany. And when we look on the other side of the casting, in this area right here that I've highlighted in blue, before I drilled that hole, which is 125 thousandths, there was nothing there. I mean, it was all the way sealed through and through, other than the cavity, of course. So the exhaust, or EPC vent relief, if you will, is actually designed into the solenoid itself. So we'll take it out real quick and I'll show you if you haven't seen one of these before. And they're not all that common because, frankly, relative to all other years, 91 through 93 is not all that common. They're not all that common when it comes to 480Es. Alright, so we can zoom in. Alright, so you have a screen here that indicates it's a vented design. So the updated electronic pressure control solenoid, which is just in this bag, is sealed. It's not vented. I got a bag inside a bag here. Make doubly sure that nothing can get to this thing while it's in storage in the warehouse or whatever. But as you can see, it's completely sealed. So when you're moving from a vented design to a sealed design, when it comes to the EPC, but you're working on one of these earlier units, you're going to have to adapt the valve body to accept it. And that's done by simply drilling a single 125 thousandths hole in this cavity here where there was previously nothing. And that's really it. That's all you have to do. So you can now run your updated electronic pressure control solenoid, and it will have plenty of exhaust passageway, or relief if you will, so that fluid doesn't pile up in there and force the solenoid itself possibly out of the valve body casting. And in a conversation with Transgo, just to make sure I double check my understanding of all of this, Rusty had let me know that one of the reasons they have you do this is to prevent the EPC from literally flying out of the valve body casting at that location. So you know, when you're using an updated sealed solenoid on one of these early transmissions. So that is basically it as far as what you need to do. Now, to identify one of these earlier separator plates and distinguish them from a later plate in the event you either get a transmission in somebody worked on but they put the wrong plate on, or you know, you're scrounging for parts because you know, either the valve body's bad or the plate is bad or something. You want to make sure you have an appropriate match, because there's nothing you need to do to the separator plate itself for these early units in terms of adaptation beyond what you did with the valve body, and that's drilling a little hole. So all we're going to do is just compare the two in the area of interest, which is in this kind of lower left corner here. And you can see, or hopefully you can see, I'm going to try to get the glare minimized. We have an EPC balance hole here, but there is no balance hole here. Okay, this hole also exists, and Transgo actually has you drill out this hole to 3/16 on all model years if you're running their shift kit. But you also notice that you have an identification indicator with these 4 little triangular notches machined out of the plate on this earlier valve body's spacer plate, but not on the later plate. Alright, as far as your feed hole sizes, this is a big block build, so you know, factory big block, low stall converter, factory low stall, and that's what this means. 93 4L80E LS means low stall, not it's fitted with an LS engine. This means high stall. There are 2 different variants, a low stall and a high stall, produced by the factory based on whether the 80 was made into a small block or a big block. Alright, so that's the spacer plate. So you just want to make sure that whatever gasket set you're using, there is a corresponding hole or orifice in the gaskets themselves. Both of them have to have a hole here, and then if you're running a 93 unit, you want to make sure that there is a hole in the spacer plate assembly, or I should say spacer plate to case gasket, valve body assembly to case. There is a hole here and a hole here for your balance hole and this little hole. So just like that. If there's not, then you'll want to make a hole. Alright. So, I'm not going to film the assembly of this valve body. I mean, I already have a valve body assembly video. The only material difference, if you even want to call it that, is the presence of the torque signal compensator valve and a corresponding very long bolt that goes right here. Goes through that portion of the housing. I mean, that's common sense. So, the purpose of this video was really twofold. One, to kind of get into this topic a little bit, because I just looked around hastily on Google and YouTube. I didn't see anything that really covers this. You know, this aspect of these 91 through 93 4L80Es. And then secondly, I also wanted to make mention and kind of show you that this is true for 1993 model year units, whereas it was my understanding, you know, as I haven't done a 93 in forever, it is my understanding, or was previously, that the Bosch EPCs that were vented were only applicable to the 91-92 model years. So again, if you're watching this as part of the addendum of the teardown inspection video, and you're maybe wondering why I was fumbling over my words, I kind of had an awkward, you know, disjointed presentation or delivery when I was discussing the valve body and the changes for these years during that teardown when I was taking it off of the case. That's why. When I saw the year and it said 93, I was, you know, that was like a curveball that got thrown at me, and I wasn't sure exactly how to hit it. So I fumbled my way through it the best I could, and at the same time I tried to give you some additional information, including, you know, putting a screenshot of the Transgo instructions there on the screen so that you saw what was going on, or at least had a better grasp of what I was trying to communicate. Alright, that'll about do it. So again, just a quick video. It's short enough to go on the back of that other video, and then, like I said, if you're watching this as the standalone version and you want to see the full carnage, because that transmission was in really rough shape, check out that teardown video, and you know, you'll see all the hard parts that we had to replace, and it's pretty interesting. All right, well, that about does it for this one. Thanks so much, guys. Really appreciate it. If you have any questions, comments, go ahead and leave below. If there's anything else I didn't cover about this particular aspect of these transmissions, 91 through 93 4L80Es, please note that in the comments as well. And if there's enough input from everybody, I'll go ahead and make a part 2 of this so that we cover everything we need to cover. The only other thing I'll comment on is the valve body itself. For the most part, is very healthy. Passed its vacuum checks with flying colors, which is unusual given the amount of problems we saw in the main case. But you know, stranger things have happened. So, you know, that's transmissions. You never know what you're going to find and what's going to come across your bench until it does. And you know, that's one of the most interesting and rewarding aspects of doing this job, is that even though the transmissions are largely the same, you kind of see something different nearly every unit you do, and you learn something new on almost every transmission you build. So, all right, well, thanks again. Appreciate you spending your time on my channel, and look forward to seeing you in the next one.